Hello, welcome to part 2 of your spring break homework. This is going to be about IOD 603, which is extrapolate from data points in a table. This skill is very similar to the last one, IOD 603, interpolate. The difference here is instead of figuring out data between 2 points, we're going to be thinking about data past known information. So either with numbers that are smaller than what is given or numbers that are larger than what is given. Okay, so to extrapolate, please take these notes down on your paper, is to expand known data into an area not known. Okay, so again, very similar to interpolate, but instead of between 2 data points, it's outside. We're expanding, but we're still estimating. To extrapolate, we need to think about what you are given. Is there a pattern or a trend? And as we're working today, we're going to be asking ourselves this question. What would come before or after a whole set of known values? Okay, part 1, what should go in the blank space? I'm going to go through an example, then you'll hit pause and try the 6 questions below. For our example, we're trying to figure out what goes in the space here at the end. So we have 0, 0.5, 1.0, 1.5, and 2.0. So we're thinking about, is there a trend with this given information, and what should come after that set value? So I see that each number is going up by 0.5. So at the end, if I have 2.5, I can expect the next number to be 2.5. Okay, go ahead and hit pause and try the next 6 questions. Okay, if you've tried these out on your own, then you should know E comes after in the alphabet. 0, 2, 4, 6, 8. They each go up by 2. Okay, the next number for 3, they go up by 3, so our final number should be 15. Okay, question number 4, each of the numbers go up by 5, so after 65 would come 70. For question number 5, it's going up by 0.05 each time. So after 0.25 should be 0.30. And then finally for number 6, it's going up by 25, so after 75 would be 100. Okay, we have 2 examples, and very similar to the last one, some of the formatting got off a little bit, so you won't be able to see the actual lines for the data tables, even though they're the same exact things that you have on your paper. So again, for extrapolate, we're going past these data sets. So on yours, there would be a blank spot right after each of these numbers. So for the position column, it goes 0, 5, 10, 15. So it's going up by 5s. So 15 plus 5, this last number would be 20. On the time side, it's going up by 1s. So it goes 0, 1, 2, 3, and then 4. Okay, press pause and try the following 2 questions out on your own. When you're ready to hear the answers, go ahead and press play again. In red is question number 1. So I see my position is going up by 0.5 each time. So after 1.5 is 2.0. Again, that number is 2.0. Doesn't look like it on your screen, but it is. And on the time side, it's going up by 0.01. So our number at the end is 0.05. Question number 2, I'm going to do here in blue. The position is going down by 1 each time, so after -3 would be -2. And our time is increasing by 5, so after 30 I would get 35. All right, let's jump in and go to the most important part of our lesson. What will the questions look like on the interim? The interim will have 3 questions that require you to extrapolate from data given in a table. In order to do so, you need to look for keywords or phrases in the question which will help you know what to do. Here are some possible questions that go along with the data table below. Sorry for the typo there. All right, again, the formatting is a little bit off here. So I see that I have my keywords, and they're going to be exactly like they were for interpolate if this experiment was repeated. But instead of repeating it for numbers in between 2 data points, we're repeating it for numbers that are outside our given set. If a number is not known, what would you expect expect the data to be? What would you estimate? So again, that word is estimate. And then what data would most likely be collected? So again, all of these words are helping us know that we are making an estimate. We're taking a guess based on what we already know. All right, I'm going to go through a couple of examples, and then you'll have a chance to try some out on your own. So again, my formatting on the screen is a little bit off. You should have one data table here, that is table 1, and then the table number 2 is right below it, where on my screen I have to move back up to the top because for some reason it moved up there. So if this experiment in table 1 was repeated with a pressure of 24 millibars, what would you expect the temperature to be? So I know I'm looking at table 1. I see this word repeated, so I know that I'm going to be estimating. And I also see what would you expect. Okay? It gives me a pressure of 24 millibars, and it's asking me to find the temperature. So I'm going to come and look at table number 1. Okay? For pressure, I don't have 24. Instead, it comes after 20. So I know I'm going to be expanding this data past this last value that I know. So if I go up by 4 here, then this side, each time it's going up by 6. So 26 plus 6 is 32. So I would expect the pressure to be 32. And I would choose B. For question number 2, according to table 1, if 2 millibars of pressure was used, what temperature would most likely be measured? So we're still on table number 1. And they give us a number that was not given. We want to know what it would most likely measure as the temperature. Okay, let's go back up to table number 2. I am not given 2 millibars of pressure. My lowest number is 6. So I know if I want to be thinking about 2, I need to be thinking lower than the data that I'm given. Okay, same with my temperature. So I see with my temperature it's decreasing here by about 5 to 6 each time. So if I'm going down by 4 on this side, then I can expect I should also go down by 5 on this side. So I have 0 degrees Celsius for my temperature if the pressure was 2 millibars. All right, so my answer choice would be A. All right, if you feel good about these questions, I would pause right now and try questions 3 and 4 on your own, and then hit play again to hear my explanation. If you still need a little bit of help, then keep listening and following along for guided practice. But I think right now would be a good time for you to try on your own and see if you are getting this. Okay? Question number 3. Using data table number 2, what would you estimate the ionization energy to be when the atom is 6 nanometers? Okay, so I know I have to look in table number 2. It's asking me to estimate, so I know I'm doing my extrapolation, and it gives me the atom is 6 nanometers, so that's my atom size, and it asks me for the ionization energy. When I look at my data table, I don't see 6. 9 is my lowest, so I know I'll be extrapolating lower than the data that I'm given. Okay, the trend here is by 3s. The trend on this side is a little bit different, right? I see 15, 16, 16, 17, 17. So it's not a great change, all right? But I do know that if I were to go lower in atom size, then the ionization energy is either going to be 15 or it's going to be 14, right? It's not changing by a significant amount, so it's not going to be 5. It's not increasing, so it can't be those. Our best choice is B, 15. Number 4, based on data in table 2, what is the most likely size of the atom when the ionization energy is 18? So we're trying to figure out the size of the atom this time, and we know the ionization energy is 18. So 18 is after the data set that we're given, so we're expanding upwards. We're only going up by 1. So we should expect this trend to continue, and if it's been going up by 3, it should continue to go up by 3. So I would have 24, which would be A. All right, so here's the time where I would like everybody to practice independently. This is the same exact data table and experiments from the interpolation part of this, but instead of interpolating, we'll be extrapolating. So go ahead and push pause, try out the 4 following questions, and when you're ready to hear the answers, press play. All right, question number 1. It asks us to look at table number 1. It asks us to find the mass of the solution if I had 21% sodium chloride, or NaCl. Okay, going back up to our data table, I have table number 1. It wants us to find the mass, and it gives us 21% here. So 21 comes after the data that I'm given, 17. And each one is going up by 3 or 4 points. So I would expect this trend to continue as well. And in the mass side, it's going up by 2.5 each time. So 10 plus 2.5 is 12.5. So I would get the answer as A. Question number 2 is in data table number 3. What would you estimate the mass of calcium chloride to be if the freezing point of a solution of H2O was negative 18.5 degrees Celsius? So I come back up here, I'm looking at table number 3. It wants us to find the mass, and we know the freezing point. Okay, the freezing point was 18.5 negative, that is, so that comes after all of our data sets. So we would expect then the mass to continue to follow that trend, and in here it's also going up by 2.5 each time. So I would have a mass of 12. Sorry, little technical difficulties. We just said that the mass was 12.5 D. All right, question number 3. According to table 2, if the experiment was repeated using a mass of 0.0 grams of potassium chloride, KCl, what would be the most likely percent of KCl used in the solution? So let's jump back up to table number 2. All right, in table number 2, I know that I am given a mass of KCl of 0.0 grams. When I look at this column for mass of KCl, I don't have 0.0 grams. The biggest or the smallest number I have is 1.5. So I know that 0 is going to come just before the 1.5. Okay, so then I know I am trying to find the percent of KCl. So the same idea here is if I'm going below the given data set, then for the percent KCl, I also want to go below the given data set. And each of these is decreasing by about 3 each time. So 3 minus 3 would be 0. So here I know that if I were to have a mass of 0.0 grams, then I would have a percentage of 0 for the KCl. I come back down here for question number 3, and my answer choice that best matches that is A, 0%. And then finally, with number 4, based on the data in table 3, if the experiment was repeated with a solution that had a mass of 0.0 grams of KaCl2, what would be the estimated freezing point of the solution? So looking at data table number 3, and I'm going to use blue for this question, if we were to repeat this again with a mass of 0.0, then I know that that is below our given data point. Okay? And I want to estimate the freezing point for calcium chloride, CaCl2. Okay, so I know that I'm going to need a freezing point that is smaller than the given information that I have available. Okay, each time I'm decreasing by a certain amount, so I know I want a number that is smaller than negative 1.47. If I look back here to my answer choices, the only number that is smaller than negative 1.47 is going to be our answer here, B, 0.0 degrees Celsius. Okay, so that is all the practice that we have for this one specific skill. The rest of the packet is combined practice. So this is going to be more like you would see on the test you'll have the first day back from spring break, but also on the interim, you're not exactly sure, do I interpolate, do I extrapolate? Okay, so this is going to give you a chance to figure out with a mixed problem set whether you need to interpolate and find between the two data points, or if I have to extrapolate and figure out is it before all of the data or after all of the data. I mean, really these skills are so similar to each other. You need to look to see what you're given and look to see, well, if we did another experiment or we use this number or this measurement instead, what would you estimate the other number to be? Okay, so in order to be most effective, I want you to hit pause and answer these questions. Okay? Without that independent practice, you aren't actually learning this information, so don't continue listening to the answers until you've tried it on your own. For question number 1, the right answer would be B. For question number 2, the right answer is A. For question number 3, the right answer is A. And for question number 4, the right answer is C. Moving on to the other passage, slightly more complicated data table, okay, but the same exact skill. For question number 1, the right answer is D. For question, that would be question 5. For 6, the answer is B. For 7, the answer is C. And for 8, the answer is A. Okay. I hope that you have found this type of lesson to be really effective and easy for you to follow along on your own at your own speed. So if you haven't understood something, you can go back and re-listen to any part that you don't understand. You can go back and rework any of the problems on your own and then listen to the explanation. Right now the learning is in your hands, so you have the choice to continue to practice on your own. If you got a lot of these problems wrong, then you definitely should go back and try again. If you got all of them right, then you know you're ready to show mastery on the test that you'll have either Monday or Tuesday when you come back to school. Enjoy the rest of your break, be safe, and I'll see you Monday or Tuesday.